So in the world of big data compute, when it talks about Velox plus Spark, it's often painted, pictures painted that the future of big data compute is hybrid. So orchestration, JVM for orchestration and the native for execution. But we saw that native can also be fully, the execution can be fully native also, like direction we saw from C++ Presto. So in last 2 days, we actually saw a lot of progress on the Velox front. And also today, we saw a lot of progress on the Gluten front too, both Velox and Gluten. For example, we saw that people are using Velox on DPP. There is iteration support on Velox. We also learned about the probabilistic data structure on Velox. We saw people are leveraging Velox for vector search. And even now we have geospatial capabilities, geospatial capabilities also in Velox, right? So, and similarly, there's a lot of progress also in Gluten side, right? Now, what is the value of all this? The real value, it comes only when there is more adoption. So there is an adoption story. Okay, good afternoon, everyone. I'm Koushik from Oracle, and I'm going to share our adoption story of Velox into Oracle's AI and data platform. As you see, I didn't put any agenda, right? Typically, the first slide is the agenda, which will explain the control flow for the slides. But I didn't put an agenda because I'm here to share with you a journey story. And a journey doesn't need an agenda. Journey may have a destination. Okay, so let's see what is Oracle's AI data platform and how does Velox fits into it, or what asked us to choose Velox into it. Okay, so Oracle's AI data platform is a unified system that brings together data, analytics, and AI into one governed environment, so you can build, run, and scale AI applications directly on enterprise data. Okay, that's a one heck of a statement, right? So let's see what it does, okay, to break it down for all of you. Okay, so it unifies all enterprise data, which basically means structured data, unstructured data, batch data, real-time data, data from multiple sources, okay? And then it helps to build data pipelines, which means basically end-to-end ETL pipelines plus data engineering system. You can ingest data, you can prepare data, you can transform data, okay? It provides catalog plus governance, which means you have data catalog, you have rollback access control, you have data, data lineage, all built into systems. It also enables AI plus machine learning, which means it supports ML deployments and the agentic AI supports. You can build agents, you can build agent applications, and it provides analytics and BI, which means you can have data explorations, you can have dashboard, you can reporting. It also provides unified development environment, which means you get a workbench, which data scientists can use to train their model, which data engineers can use to build their pipelines, which data analysts can also use to run their notebooks, basically giving a single pane of experience, single pane of glass experience. It provides storage and database layer. So storage is basically supported by Oracle Cloud Infrastructure, OCI's, and OCI's Object Storage. And we also provide Oracle Automated Database for curated data. Okay, and then we have support for end-to-end lifecycle support. Basically, you ingest, you prepare, you train, you deploy, and use everything end-to-end in a single system. Okay, so the primary thing is that we eliminate the need to glue together multiple systems. Okay, so let's step it down to the thing that makes more sense to our talk today. Okay, so there are multiple user entry point in the Oracle AI data platform. User can use a notebook, can use SQL queries as API endpoints, and then we provide unified workspace to work by the users. But the processing is done by the Spark. So that's the main thing. The distributed processing is supported by Spark engine, and then the OCI Object Storage provide the fundamental foundational data lake layer. Okay, so then the two important aspects that's useful for this talk is that we and the AIDP uses Spark-based processing for data processing, and then OCI Object Storage for data lake. Okay, So these are the two things that's important to ask. Okay. So now, since it uses Spark-based distributed processing, then of course we wanted to have Spark acceleration. We wanted to improve the query performance for our AI data platform. Okay. But we start thinking from the perspective of an user. Okay, so basically the rationale is that we don't want to we want user to give faster query performance, and we also wanted to save users compute cost. But at the same time, we don't want any customer visibility, any customer visible complexity. So if there is a changes, we should change from our side. As far as customers are concerned, their Spark APIs should remain unchanged, their SQL queries should remain unchanged, their notebooks should remain unchanged, their workflow jobs should remain unchanged. Okay, all the changes to enable the native executions or to allocate the off-heap memory should be handled by us from the backend. Okay, so now Gluten plus Velox somehow serve this purpose very well. Especially Velox helps with the fast executions, and then Gluten can take care of the seamless fallback for the operator that Velox doesn't support. So that's a kind of fit the bill very well for our use cases, where we can do all these changes from backend, and our customer automatically start getting the performance benefit for their SQL jobs, or for the data from job, or for their workflow jobs. Okay. So keeping this in mind, we started our journey to integrate Velox and Gluten into our Spark pipeline. Okay, Spark processing engine. So that's the journey starts. Okay, so I'll share some of the challenges and what we went through and the result we saw. We just started actually. So the first challenge actually didn't come from Velox. The first challenge came from Gluten. So in Oracle, we use Oracle Linux for our development, and so we needed to bring support for Oracle Linux into the Gluten code base, to set up the thing and free ourselves. Plus, we need to do few wiring and configuration, and then also few of the authentication stuff, so to unblock us. Okay, so with that in place, we are ready for Velox and Gluten integrated into our Spark system, and we wanted to then run a TPC-DS query and to see the result. Okay, so let's look at the number together after our fast integration with Velox and Gluten. Okay. Okay, so I don't know how do I put it. I can say surprise, 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 or I can say shock, shock, shock. If you look at the numbers, you will see that a few queries definitely we saw good improvement, but there are a lot of queries there is not much improvement. I mean, plain vanilla Spark had actually better performance than Spark with Velox and Gluten. Okay, so that's kind of initial shock to us when we started. We didn't have by the time we still didn't have the full scope of the work figured out. We're still doing the POC, and so it turns out that just integrating Spark, just integrating Velox plus Gluten is not sufficient to give you full impact. Okay, as you can see the query here, we also need support for native scan, native scan for OCI Object Storage. Okay, and that was not present in the Velox when we started this work. Okay, so in the absence of native scan, what happens? The Spark it goes to the JVM scan, and with the JVM scan, with Velox and Gluten, you don't see, you see kind of mixed kind of result, right? So it's clear that we need some storage I/O support. Just not that Velox and Gluten is not sufficient. Okay, but it's a valid question for a beginner who are new to this space and who are trying to integrate, right? First time, it's a very fair question, right? If you wanted to compare with a plain vanilla Linux. Plain vanilla Spark with a Spark with Velox and Gluten, we know that the Velox bring memory efficiency in terms of columnar format reading, and also Velox bring the compute efficiency in terms of SIMD, taking advantage of SIMD. So, and then native scan was JVM native reader even in the plain vanilla Spark, and it's also JVM native reader in the Velox plus Gluten. So so then why with a compute memory efficiency we're not seeing gain for all the queries? I mean, we should see gain from all the queries. May not be for as much impactful as with native scan, but we should see gain definitely, right? So it turns out that when you bring Velox plus Gluten into the ecosystem, the complete dynamics change a bit. Okay, so now you actually, though you get some gain from in terms of compute memory from Velox, you also pay some extra taxes. Okay, so one is that when the reading is having by JVM, you copy the data from OCI Object Storage to JVM structures, and then you copy that to Velox native columnar format. So there is two copies happening unnecessarily, which means basically we are having some redundant data movement there. So that is one tax. Plus, you're also doing a conversion. So I call it format conversion tax. Basically, converting from you're reading as a row format and then converting to column format, and that is again unnecessarily coming because we don't have any native reader there, native objects OCI reader there. Okay, and these things will happen every execution boundary. So for example, in JVM, native JPN, when there's a fallback, every time you'll end up paying this extra compute and memory tax. So for some queries, it turns out that the amount of the loss you'll have because of this extra tax will actually outweigh the gain that Velox bring. Okay, that outweigh the compute gain that Velox bring. Okay, so with that analysis, it's very clear that we actually that Velox plus Gluten with Spark is not sufficient for AIDP. We actually, though Velox brings compute memory efficiency, you also need the storage I/O support. So basically, need the support for writing an OCI connector in Velox, right? Now, so that becomes our next challenge in the journey. That now you write a new connector for your object storage. Okay, we don't have that in the code base ready, and so that's both good news and bad news. Okay. So the good news is that to write a native OCI connector, we have to implement the custom Velox file system interface, and this interface is very well abstracted in Velox. So implementation has become relatively easy. And also there are other storage systems like S3 and the Azure and then GCS. They have already implemented their connector. So you have some precedent also here. But we have bigger challenges waiting for us. Unlike in S3 or GCS or Azure, we don't have any C++ OCI SDK for OCI. Okay, we have Java SDK, we have Go SDK, we have Python SDK, but no C++ SDK. And you need that thing in place, like in the entire network plumbing and authentication in place that you can use to implement your OCI connector. Okay. So then the scope of the work becomes now bigger, right? From writing one connector, you have to now write an entire SDK for your storage and then use that to build your connector. So the scope of the work has now increased. Okay. So then the question becomes, is it worth it? I mean, are we going to really get that much of gain to take such a bigger scope now, right? To produce a new SDK also. So we say that if we can do some POC, without taking that deeper work, bigger work, and can produce that, okay, it's indeed the right path, then it will be helpful. So fortunately, we had some help there. Okay, we have the OCI actually has some S3 compatible endpoint support. So, and OCI provides some S3 compliant endpoint support, which one can use using an S3 connector. And also, fortunately, the Velox has S3 file system already built on AWS C++ SDK. So it's available in the Velox code base. So we said that, okay, if we have already S3 connector, and we have a way to connect access OCI Object Storage using an S3 connector because we provide that endpoints. So why not use that path and do a POC, right? And see that, okay, the things are working before we take a bigger work. Okay, at least for POC it's good enough. It's not good enough for the production use case because in production we'll need a lot of OCI specific authentication support, OCI specific network plumbing. So those will need bigger work. So instead of going such a big work, let's do a small POC with this and see that it's working. Now this time results was actually encouraging. Okay, I didn't show the result here just for you. Let's save it for with the native connector. And so with that encouragement, we actually went ahead and implemented our C++ SDK, miniature version of a C++ SDK, and with all OCI specific implementations. And then we use that to implement our Velox file system interface. And then we also brought the wiring in the Gluten so that now end-to-end things are in place. Okay. So with all this in place, now we can celebrate the result. Okay. So let's quickly celebrate the result. And we run TPC-DS query this time, and you can see that with a scale factor of 100,000, we have almost all the queries have better result except for 3 queries. And you can see that top 10 queries are really have good results. Some of them have 7x to 8x improvement. And same result we saw with 1,000 scale factor TPC-DS queries. If we take a top 10 improved queries, you see again the very good impact. Some of the queries 7 to 8x improvement here too. And I can also see similar thing with the 10 scale factor. You see almost all the queries has now better improvement when everything is end-to-end. Okay, I mean from Spark to Gluten to Velox to native connector. Okay, and you can see that some top 10 queries also have very good improvements. Okay. So with that, we have things in place, and we integrated entire thing with our Oracle Identity platform, and we have actually make it available to our customer to use. So what is our contribution to Velox community then with this work? Okay, we just started. So I mean, our primary contribution is adoption. Adoption is the primary contribution. Let's say more people adopt, it encourages more other people to adopt, and it also bring more use cases and bring a compounding effect. So I'd say that's a first, very small, impact. Plus, there's a little tangible impact also, tangible contribution also. If you look at the Velox code base, you will see that Velox has, as I said, there's a storage adapter for GCS and Azure and S3, but there is nothing for OCI. Okay, it's missing from the code base. And if I quickly show you a snapshot of MUM8, you can see OCI there. So that's the tangible contribution to start with. Okay, we need to just refactor out the SDK part, then we can push the changes to this thing. Okay, so yeah, so I didn't add any concluding slide because we didn't conclude. It's just the beginning. Its journey will continue, and we'll have more stories to share with you. Thanks everyone for patient hearing.